Look at this loop. It has 6 lines. It does 3 jobs at once. It loops, checks a condition. It builds a new list. Now look at this. 1 line. Same result. Faster to read. Harder to break. This is the difference between beginner Python and senior Python.
Ay majas.
This is episode 31, Functional Tools. Map, filter, zip, enumerate, sorted with a key, lambda, partial, reduce, 8 tools. 1 pipeline at the end that uses all of them. By the end of this video, your for loops are going to look very different. Let's go. Let's start with map. Map takes a function and an iterable. It applies that function to every single item. Look at the loop version first. We build an empty list. We loop through prices. We append each price times 1.1. For lines, just to apply tax. Now the map version. Map of a lambda, comma, prices. 1 line. Map doesn't return a list right away. It returns a map object, lazy, memory efficient. Wrap it in list to see the result. Same output. 1 line instead of 4. Rule of thumb. Loop only transforms each item. Reach for map first. Now filter. Filter keeps only the items where a function returns true. Look at the loop version. Empty list. Loop through scores. If score is greater than 50, append it. 3 lines for 1 condition. Now filter. Filter of a lambda, comma, scores. 1 line. Same passing scores, same order. Filter is also lazy. Wrap it in list to see results. Here's the pattern that matters. Map transforms every item. Filter keeps some items. You can chain them. Filter first, then map clean and pure scores, then apply the curve. 2 tools, 1 readable line. Zip walks multiple lists together, 1 item from each at the same time. Here's the beginner mistake. Looping by index. For I in range len names, then names of I, scores of I. It works, but it's fragile and ugly. Now zip. For name, score in zip names, scores. No index. No range.
No len.
Just the 2 values paired every iteration. Zip stops at the shortest list automatically. 3 names, 2 scores. Zip gives you 2 pairs, not 3.
No index error.
Want 3 lists at once? Same syntax. Zip names, scores, grades. 3 values per iteration. This is also how you build a dictionary from 2 lists. 1 line. Dict of zip keys, values. Enumerate gives you the index and the value, together. The mistake almost every beginner makes. For I in range len items, then items of I. It works, but you're tracking index manually for no reason. Now enumerate. For index, item in enumerate items. Same result. Cleaner. Want to start counting from 1 instead of 0. Enumerate items. Start equals 1. 1 extra argument. That's it. Here's where this matters most. See range len something in your code? That's a signal. 9 times out of 10, enumerate replaces it completely. Let's do a live refactor. Watch this transform in real time. Here's our starting loop. 6 lines. It filters even numbers. It doubles them. It tracks the running total by hand. Step 1, replace the filter logic. Filter. Lambda n:(n mod 2 equals 0. Step 2, replace the transform. Wrap that in map. Lambda n:(n times 2. Step 3, replace the manual total. Wrap the whole thing in sum. Watch the lines disappear. 6 lines. Now 4. Now 2. Now 1. Sum of map. Lambda n times 2. Filter. Lambda n mod 2 equals 0. Then numbers. Same result. 1 line. This is the moment it clicks for most people. You're not memorizing syntax. You're learning to see loops differently. Quick 30-second favor before we keep going. Did that refactor make sense? That 1-line moment? This channel is for you. 1 subscribe helps this video reach more people stuck writing 6-line loops right now. Tap it. Takes 2 seconds. Okay, back to the good stuff. For more tools left and the mini project where we use all 8 together. Sorted can sort anything if you give it a key. Sorting numbers is easy. Sorted numbers. Done. But sorting a list of dictionaries by 1 field? That's where key comes in. Sorted students. Key equals lambda s:(s bracket (quote)age). Read that as, for each student, look at their age, sort by that. Want descending order? Add reverse equals true. One more argument. Want to sort by two fields, age, then name? Return a tuple from the lambda. Lambda s:/age, s name. Python sorts tuples left to right automatically. Key turns sorted from a number-only tool into a sort-by-anything tool. Let's talk about lambda properly because most tutorials get this wrong. Lambda creates a small, throwaway, unnamed function. Lambda x:(x times 2. Same as a regular function with one line and no name. Here's the rule that matters. Use lambda for short, one-time logic, usually inside map, filter, or sorted. Do not use lambda for anything with a name worth keeping. Not for multiple lines. Not for anything you'll reuse elsewhere. If you're naming a lambda, calculate equals lambda x:. Stop. Just write def calculate instead. Naming a lambda defeats its entire purpose. Functools.partial locks in arguments ahead of time. Here's a power function that takes a base and an exponent. We want a square function and a cube function, without writing two new functions. Partial of power, comma, exponent equals 2. That's square. Partial of power, comma, exponent equals 3. That's cube. Call square of 5, 25. Call cube of 5, 125. Partial is basically a factory function, but built in. One line. No nested def needed. You'll see this constantly in real codebases. Logging pre-filled with a prefix. API calls pre-filled with headers. Callbacks pre-filled with config. Reduce collapses an entire list down into one value. It's the least used of these 8 tools and the most misunderstood. Reduce takes a function and an iterable. The function takes 2 arguments, the running result, and the next item. Reduce of lambda acc, n:(acc times n, numbers. Walk through it. Start with the first 2 numbers, multiply. Take that result, multiply by the next number. Keep going until the list is empty. End with one final number. This is literally how a factorial works. This is literally how sum and max could be written from scratch. Use reduce when map and filter can't get you to a single final value. Important, these tools are not always better. Sometimes a for loop is still the right choice. Use a for loop for multiple side effects per item. Printing and logging and updating a database. Use a for loop when the logic needs more than one line. A lambda would be unreadable there. Use a for loop when you need to break early or use continue. Functional tools shine for one clear transformation. For loops shine for multiple steps per item. Senior developers don't avoid for loops out of fear. They pick whichever one reads clearest. And that's the actual skill here. Mini project, a real data pipeline. 0 for loops. 8 tools, 1 task. We have raw sales records, name, amount, region. Step 1. Filter out anything under $100. Step 2. Map each record to add a 10% bonus. Step 3. Sort by amount, descending using key. Step 4. Enumerate them for a ranked leaderboard. Step 5. Zip the names with their final rank. Step 6. Reduce the amounts into one grand total. 6 steps. 0 for loops. Every single line reads like a sentence. Filter the valid ones. Map the bonus. Sort by amount. Rank them. This is the pipeline style used in Pandas and PySpark. Every data tool you'll touch in AI work. Your challenge. Build the same pipeline, your own data. Step 1. Filter your data on one condition. Step 2. Map a transformation onto it. Step 3. Sort it using key. Step 4. Enumerate the final ranked list. Step 5. Use reduce to get one summary value. Bonus, do it with 0 for loops and 0 lambdas named with a variable. Paste your pipeline in the comments. I read every single one. Let's recap. Map, transform every item. Filter, keep only what passes. Zip, walk multiple lists together. Enumerate, index and value, together. Sorted with key, sort by anything. Lambda, small, one-time, unnamed logic only. Partial, lock in arguments ahead of time. Reduce, collapse a list into one value. And the most important lesson, for loops aren't wrong. They're just not always the clearest tool. Next episode, the collections module, counter, defaultict, deek. Subscribe so you don't miss it. See you tomorrow. Functional tools unlocked. Your loops just got a serious upgrade. Map, filter, zip, reduce. This is what senior Python actually looks like. Subscribe for the next episode. Drop your pipeline in the comments. I'm Mahaz. See you in episode 32.